Alright, this is problem 5 for homework 7. Wow, this question was a little bit of a doozy. Okay, so for part A, we're being asked about the speed of the block at point B. And we know that the total energy in a closed system like this is conserved, because it's conservative force. But either way, so we know that the total energy is potential energy plus kinetic energy. Potential energy, well, let's start with kinetic energy because that's what I did. Kinetic energy is 1/2 mv squared, and we're given an original v. So we can find kinetic energy in terms of m by just doing 1/2 m times by v squared, whatever your v is. In my case, it's 6.5. So if you do 1/2 m 6.5 squared in my case, you get your kinetic energy at the beginning. This kinetic energy does not disappear. It's always still here. So from the difference from A to B, however, is this potential energy, which is just m times g times h. We know what h is. It's equal to h1, obviously. Well, delta h1, I guess, which is 5.5. G is just 9.8, and we don't have m, so we'll keep it in terms of m. But don't worry, it can be factored out later. So then we take our potential energy that we got from mgh times by our ke, which we got from 1/2 mv squared. Use your own numbers, and then make sure you don't round to a million people who've got questions around from rounding. It's pretty common at this point. So then you should add them together. So then note, and then when you add your PE and KE, you get the total energy of the system. At point B, one of the important realizations is that all your energy is turned into kinetic energy at this point, because it's defined at h equals 0. It's on the ground right now. We're counting B as the ground. So if it's on the ground, it has no potential energy, it's all kinetic energy, which means you can set this PE plus KE, which is this, whatever you got, you can set this to be all converted into kinetic energy, or set it to equal 1/2 m nu v squared, like your v at point B. So I should have called this VB to be more clear, but you can call it whatever you want. It doesn't really matter. So then times both sides by 2, divide both sides by m, because you realize there's m on both sides, and then you should get v squared, and then you should get v. So that's part A. Part B, where they ask for point C, is incredibly similar. But imagine instead of it dropping from here, since the path does not matter at all when it's conservative force, it's only the end and start point, just imagine it was a straight line from A to C. So we do the exact same thing, the exact same KE we start with. It's still 6.5, or in my case 6.5 squared, times m times 1/2. But then the change of h is the change of h1 minus the h2, or in my case 5.5 minus 2.9. So for our potential energy, which is mg delta h, it would be, in my case, it would be mg 2.6, because that's 5.5 meters minus 2.9. So you find your PE from this case, which is just mg, and then your delta h, which should be h1 minus h2. Your KE is the exact same number. So then you add your PE and your KE to get your total KE at point C. And then you go through the same process of setting it all equal to the kinetic energy at point C, 1/2 mv squared, times both sides by 2, divide both sides by m, you get v squared at point C, and then you get v at point C. Pretty simple. And then for C, we're being asked if it reaches point D. Well, we know that if it needs to reach point D, it needs to have more energy than it takes to get through this length of friction. And the energy to get through the length of friction is the work, or I'll just put it in the way that we probably know it, which is the mass times the distance times the coefficient of friction times the normal force. because the normal force in this basically gives you the, I guess, the resistance that friction is putting up. And this is just, well, pushing a mass a certain distance. That's just energy. So you take your mass, which you don't know, but you can leave it in terms of m, times by the distance, which you do know. It's 12 in my case. You will see it here. Use your own numbers. Then you multiply it by your UK. Then you multiply it by your, I forgot to put normal force in here, but I put 12 again, but it should be 9.8. 9.8. And then you should get your, this is technically a friction force, or thermal energy, if you will, because friction, when it opposes movement, causes thermal energy. So this means you need this amount of force to get through the friction area. But recall from the last question, we've got the amount of, not force, amount of energy. But recall from the last part from B, we got the energy we already have before this point. It was a smaller number. Here it's 46, while we need 84 to get through. So we know we're not going to get through. So how far will we get through? Well, we need 84 point whatever of joules of energy times mass. Just forget the mass because it cancels out. But we only have 40. Yeah, it should be 44, I think. Either way, your numbers will be different. 44, 46, or some other number. So what you take, if it doesn't go through, you take your number that you do have at point C, divide it by the amount it needs to go through. So in my case, it's about 55% of the way through. Because since you have just about 55% of the energy, you'll get about 55% of the way through. Now, if yours was strong enough to go through, you would have to find the difference. Because if it was strong enough to go through, obviously your force would be higher at point C than what you need to get through from the friction. So then you just minus them, and then you just do 1/2 mv squared again, but with the new difference between what you do have and what you need to get through.